Good morning, people. Am I audible?
Yes, sir.
Yeah, thank you very much. I think Google Meet guys have changed the whole setup. As such, this looks much compact and interesting, I would say. Not many features added as such, but looks different. Anyway, so I don't know how many of you all have gone into the details of what Devrishi had yesterday posted on the group as such. But if you ask me personally, that aspect was a bit making things a bit more complex, I would rather say. And the geographer in me always says that you should make things easier for the layman. Okay, say for example, you have scientists in the world. How many scientists may you have in the whole world as such? Okay, a few million as such. But you have people who are billions, and remember that many of these are illiterate. Many of these live in far-flung areas, and they don't have access to technology. And leave aside technology, they don't have access to education as such. So I always tell students that geography has a special task of making things much easier for uh, the layman, I would say. Everything that is done and resolved and solved by uh, scientists tends to be explained in the easiest way uh, to the layman is what I feel is one of the major functions of geography as such. And with that reference, I would once again go back to what we were doing yesterday. And this is what we were doing yesterday, isn't it? So I had just put this up in magnifier scale. And yes, we were speaking about these two things. Okay, here we have already said this, and let me tell you that we have been doing this from school days, but never have we ever. I don't know how many of you all asked your teachers that what is the geometry of it, and so on and so forth. Okay, this is tilted at a 23.5 degrees. Now, just for the fun of it, let me give you two things, two facts, and how we need to understand the geography of all these things. Okay, the Tropic of Cancer and Tropic of Capricorn is, sorry, this is on, so to say, yeah. The Tropic of Cancer, let us say, is 23.5 degrees. And the Arctic Circles is 66.5 degrees. Now, if I add these together, okay, this comes to 90 degrees. So you'll see that all this falls in perfect geometry. And we need to post this geometry in understanding the geography of all these issues as such. And that's why I would once again now put this up in this particular. Now, I don't think I need to repeat the days of the equinox. And this is the summer solstice for the northern hemisphere. That's June 21st. And this should be happening in some days from now. And see how this is going to be placed. We'll be discussing this in detail. I have a small clip on that also. 3 months down the line, 22nd and 23rd of September, we are going to have an equinox position wherein you'll see that this axis of the Earth is neither towards the sun or away from the sun. You see that in these two positions, okay, it's the North Pole is towards the sun. Here, the South Pole is towards the sun. So that makes all the difference of climates on the surface of this particular planet. Now, having put this 23.5 degrees and 66.5 degrees and adding it to 90 degrees, what impact does it make overall? Okay, now just let us look into this aspect also. Now, this seems to be the winter solstice, isn't it? Because you'll see that if we say this is the north, yes, it's written this is the northern hemisphere. This is tilting into the dark, so the sun is going to be the sun's rays as this marked here Okay, the sun's rays are away, are coming from this particular way, and the southern hemisphere, south pole is here as such. Now, what actually is happening can be seen here as such. Okay, they have purposely marked these angles. Okay, you'll see that a right angle, a right angle of the sun's rays is actually on 23.5 degrees. Right angle is actually at 23.5 degrees. A lesser angle, it's not as high as 90, but lesser than 90 is actually at the equator. And then you have the Tropic of what is this? Tropic of Cancer, which is at a lower angle. And in fact, you'll see that this point here, is at 180 degrees, isn't it? So you'll see that on these days, that's the summer solstice and the winter solstice. The positions are very, very interesting in the sense that the sun's rays bring in the heat, isn't it? And I've told you all that all that happens around us as a matter of fact of climate over a period of time, and as a matter of fact, as far as weather is concerned, as far as day-to-day changes are concerned, you see that this is all to do with the energy that comes from the sun. Not directly, as we have said that the upper layers are going to absorb the short waves, but eventually it's this energy that strikes the earth, and then the earth re-radiates this in the form of long wave radiations, and that is how it starts heating. What reaches the earth is decided by these angles. How intense it is decided by this particular angle. Okay, that's the most interesting part of it. But as I said, the geography of these lines, because as a student of geography in my school days, I used to just curse these lines basically because I used to say, why the hell is Tropic of Cancer 23.5? Why the hell the Tropic of Capricorn is 23.5? Why see if these are imaginary lines, latitudes, human beings could have placed them as either 23, 24. To make it more simple for students of 5th and 6th standard, it could have been 25. It could have been so very easy. But as I said, it has to do with the geometry. Now you'll see that this 23.5 year has certainly to do something with this 23 year. So you'll see that on December 23rd, which we assume to be take this particular day here as this, for this, December 23rd of December is the day where the Earth comes into this particular position. Okay, you'll see that the northern pole is tilted maximum away from the sun, while the southern pole is tilted maximum towards the sun. That's one observation. The second observation is that the sun's rays, which otherwise we assume to be parallel to the, or rather I would say perpendicular to the equator, actually are perpendicular on the Tropic of Capricorn. That's the most interesting thing and important thing that we have to remember. December 23rd, the sun's rays are perpendicular on the Tropic of Capricorn. What does this also mean? What would happen on December 24th? Would they move ahead? No. They start moving back towards the equator. They start moving back towards the equator. And as a consequence, you'll see that as far as, where is it? Okay, if this is December that we were speaking in context of, you'll see that on equinox, that's March, you'll see that the sun's rays are going to be parallel literally on each of these, basically because the sun's rays tend to get parallel to the axis. They get parallel to the axis. Now, what does that mean? That means that the perpendicularity of the sun's rays, which is very important as far as the insolation of the sun's energy is concerned. Insolation is an abbreviation for incoming solar radiation. It's with this that the energy from the sun is brought onto the surface of the earth. So obviously, where insolation is going to be more, the heat is going to be more. Now, there is a another interesting aspect about this. I'm going to ask a question about this later. I did post you all a question yesterday. I don't know. I think it's this very thing that I was referring to yesterday as such. Now, anyway, so you'll see that if on 23rd of December, the sun's rays are going to be parallel, sorry, perpendicular on the tropic of Capricorn. Obviously, in June, the sun's rays are going to be parallel on tropic of Cancer. Okay, you can see this cursor here. It's going to be parallel, sorry, perpendicular on the tropic of Cancer. What does this mean in geography? Or what does this mean to the, say, common man, the layman as such? Okay, let me tell you that the perpendicularity of the sun's rays in that case, keeps on moving between 23.5 degrees south and 23.5 degrees north. Now, let me remind you, even I got carried away with it. This is 30 degrees and this is not 20. So 23.5 degrees north is going to be somewhere here as such. So what I mean to say is the perpendicularity of the sun's rays keeps on shifting between 23.5 degrees south and 23.5 degrees north. Every place between 23.5 degrees north and south is going to have perpendicular rays of the sun at least 2 times in a year. And any idea what this particular day is also called as? And it happened just a few weeks ago. Anyone will tell me what this day that the sun's rays is perpendicular wherever you are staying, if in fact you are staying between 23.5 degrees north and south as such. And we all means Maharashtra totally is within 23.5 degrees as such. You will have to unmute yourself because I'm not able to see your comments if you are posting comments as such. But for a moment, you could just unmute yourself. And let me tell you, if you are using a computer or a laptop, you can just use the space bar to unmute yourself for a few moments. So that's something that I've learned recently. You use the space bar and you unmute yourself for just a moment of time. Um, what is that day when the sun's rays are perpendicular when where you are staying as such or living as such? Therefore, two. That is also called as the zero shadow day, because obviously, if you are going to be exactly below the sun's rays, okay, your shadow is going to be beneath your feet. Now, let me also again tell you that this may not happen throughout the day. You will have to wait for a particular time where the sun gets exactly to the zenith, and your shadow will crouch beneath your feet. And for Pune, let me tell you, the time is 12:33. Now, my question for you again, and that's going to be on homework. Let's see if you can remember till the next Monday. That why is it if noon time is called as 12 called at 12 o'clock? Why is it that at Pune the zero shadow time is somewhere between 12:30 and 12:35? Okay, 12:33 to be more precise, but then it keeps changing a bit here and there. I would say it's not at all 12. It's not even 12:30. It's somewhere beyond 12:30 and 12:35. There is again some very interesting logic behind this. I would like you all to just get back to that. So all the points between 23.5 degrees north and south will get perpendicular rays of the sun only only two times. But these two lines, that's Tropic of Cancer and Tropic of Capricorn, by the way, will get their perpendicularity of the sun's rays only once. Only once. That's so the Tropic of Cancer, it will be June 21st or 22nd, and the Tropic of Capricorn is going to be December 23rd. What does that also mean for the layman? It also means that points beyond 23.5 degrees north and south, points beyond 23.5 degrees north and south have never experienced perpendicularity of the sun's rays. The Himalayan range has never experienced perpendicularity of the sun's rays. Delhi, which gets very hot in summer, still does not get perpendicular rays of the sun. Jaipur has never got perpendicularity of the sun's rays, basically because they lie beyond 23.5 degrees north latitude as such. Okay, all this, Meghalaya and Assam, and of course uh, um, Himachal Pradesh, Punjab, Haryana, they never come under the perpendicularity of the sun's rays. So this is very important. And that's what makes the zone between the two tropics, that's the Tropic of Cancer and the Tropic of Capricorn, known as the tropical region. Okay? It lies between the tropics, which experiences the perpendicularity of the sun's rays, and that's why they are. It's in fact called as the tropical region. Beyond the tropics, you come to the temperate regions. Now, the next interesting thing I would say, we will be speaking about a lot of interesting things, but then you'll see I want you all to look at this darker side and of course this illuminated side as side of the earth as such. Okay, this is called as the zone of illumination and this is called as the shadow zone as such. Okay, now if if you'll see that if I'm going to see the line that runs through, okay, the line that runs through the light and the darker side of this particular planet, this diagram that you can see. What interesting thing that you can is what you can note. Okay, you will see that this line that separates light and dark, it starts from 66.5 degrees north and it ends at 66.5 degrees north. That's the fantasy, that's the wonderfulness of nature. And that's obviously the wonderfulness of this tilt that the Earth's axis has to the vertical as such. Okay, now coming back to the fact that this is the summer season for the southern hemisphere. This is the summer season for the southern hemisphere. As a consequence, you'll see that this whole line of 66.5 degrees south, this whole line of 66.5 degrees south lies in the illuminated zone, lies in the illuminated zone, and this whole line of 66.5 degrees north lies in the shadow zone. What does this mean? Please don't jump to conclusion in your minds even if you are doing that. Okay, when I ask this in class, I get these answers that you are going to have 6 months of day, 6 months of night. No, sorry, it does not happen that way. Okay, I'm asking you a question related to only all those places which are lying along 66.5 degrees, either north or south. 66.5 degrees north is completely in dark. 66.5 degrees south is completely in illumination. If you remember, I said that once its job is done, okay, remember that the earth is moving at its own axis and the earth is also moving along its orbital plane. Okay, so as far as this movement is concerned, even if we are to speak about it at a micro level, okay, you'll see that the equator, if you are standing at the equator and you travel for 24 hours, you come to the same point at which you had started from. This distance is 44,000 kilometers. How much is it? 44,000 kilometers. And you don't even feel it, traveling 44,000 kilometers within 24 hours. Leave that aside. If we are to speak about this aspect, the sun in the center, and these four positions of the earth. By the way, let me also make you aware of the fact that this is, I would say, academic liberty that geographers take when we put this, because this is one of the most famous diagrams that we tend to learn in geography as such. Remember, there are two things in this particular diagrams, or I would rather say there are two flaws in these diagrams, in this diagram, which needs to be understood. Okay, it need not be corrected in the diagram,
but it needs to be understood. The first thing is the size of the sun and the earth. Okay, you'll see that given the sizes of the earth is heavily enlarged, particularly given the size of the sun that's towards the center of the diagram. That's one thing. Okay, you'll see that I would say that the sun is in fact this size and the earth would be just this size, just this. So I would say if the sun is a watermelon, I would say the earth would be as small as I can't even imagine how small I would place the earth to be if I'm calling the sun to be a watermelon. But um, mustard, if you have seen mustard grains, okay, jeera, sorry, not mustard, that's mm, any small berry you would take, okay, you will have to compress that berry further small, and that would be the size of the earth in front of the sun as such. And that brings about another dilemma that I see students facing, but that is for some other day as such. So that's one thing that we have to remember. And as shown in the diagram, however, the orbit of the Earth around the Sun is not a perfect circle. It's an elliptical orbit. And in fact, let me tell you that the Earth gets nearest to the Sun during January, this part. And that is called as the perihelion position. Perihelion position, you must have done this in your uh, earlier classes. And this is when the July is when the Earth gets farthest from the Sun, and that's called as the aphelion position. Aphelion. Helios is basically called, the sun is called as Helios. Helion is basically fire. So perihelion and the aphelion. Why I was referring to this is that during perihelion, the Earth gets as near as 148 million kilometers from the Sun, and aphelion is as far as 152 million. Now, even if we average this to around 150 million kilometers, if we are to gauge this circumference of that circle, then, okay, obviously this radius, this is going to be the radius. So formula for the circumference, if it is 2 pi r, okay, so it's going to be 2 into 3.14, let us say, into radius is 150. Okay, so 153 times is going to be how much? 450, and that again 2 times is going to be 450, 900.
You are traveling without feeling it. Every one of us is traveling 900 million kilometers. 900 million kilometers, a free ride of 900 million kilometers on the surface of the Earth every year. Just imagine 365 days, 900 kilometers. You can just come down to the speed at which we are traveling. Why I was referring to this is basically because if you actually see, I have given you all that app, weather and radar. If you actually see on the equinox days, the sunrise and the sunset is not the same everywhere. Though we have generalized it, though we have standardized it to be 12 hours and 12 hours of day and 12 hours of night, it actually doesn't happen so, because the earth is moving at such a huge speed that I would say that solstice is not a day. It is not a day, 21 or 22nd of June or 23rd or 21st or 22nd of December. It's not the whole day. It's just for that moment that the sun, that the earth passes from that particular location.
And that's very important to keep in mind as well. Okay, the whole day it doesn't keep waiting there. It keeps moving. It's moving at a tremendous speed, unimaginable speed as such. So anyway, now in this process, what happens is those lines that we were speaking about. Okay, what do those lines indicate for us? Just give me. Yeah, these two lines, the Tropic of Cancer and the Tropic of Capricorn, what do they indicate to us? The whole line on that particular day, the whole line on that particular day, on that particular day only I would say, is in the illuminated zone. So it is on this day that you're going to have a 24 hours day at 66.5 degrees south. At the same time, you are going to have a 24 hours night for the first time of that season. Let me tell you, 24 hours of night along this particular latitude, at 66.5 degrees north. This, let me tell you, is going to be the first time for that particular season. This is going to happen every year, let me tell you, on those respective days. Okay, so this is very important and has to be kept in mind. Now, there is one more thing that I am tempted to share with you all here, as such that particularly this sun, this darker sun, does that mean that the sun's rays, or rather the light in this particular area is going to be very, very dark? Let me tell you, no. Okay, what this means is that along 66.5 degrees south, the sun is just above the horizon, and 66.5 degrees north, the sun is just below the horizon. Just below the horizon. That does not mean absolute dark. And that it's just above the horizon also does not mean that it's absolute bright. Now, why is it not absolute dark? The concept of diffused light. Okay, the same way we see each other in rooms, though the sunlight is not directly in touch with us, is what is experienced along 66.5 degrees. So it's an hypothetical condition, and that's why we say that the sun is beneath the horizon. Beneath the horizon. That does not mean that it is absolute dark, let me tell you. It cannot be absolute dark because the atmospheric layer has a lot of dust particles, particularly the troposphere, and that's going to be reflecting, refracting, diffracting, diffusing different types of sun's rays through these dust particles that pack up these things. And that's why you are not going to have it absolute dark. It's going to be twilight conditions along this. Okay, many students are confused about all these things, and that's why I thought of speaking of this at a length, along with the other things that I uh, was supposed to be referring to. Yes, anybody has a question? Somebody has unmuted herself or himself. Okay,
Sorry, sir.
yeah, please. No questions? Okay, now what I'm going to do is I am going to stop sharing here. We go back to a few concepts that we need to understand. And I will come back to, yes, I'll just go through some equinox, 21st of June. Okay. In call message. Anyway, there are a few things that I have for you, and let me take those out. First of them is, sorry, the same thing that we have been doing about what are seasons actually. Let us see in a short thing what actually do these seasons mean for us.
How long does it take the Earth to make one complete rotation around its axis? 24 hours or 1 day? If we look at the same image of the globe, but from the top, looking down the axis from the North Pole, we see the Earth is rotating counterclockwise around the North Pole. If we look more carefully at this axis of rotation, we see that it is tilted relative to Earth's orbit around the Sun. Instead of being perpendicular, it's tilted 23.5 degrees. How long does it take the Earth to make one complete orbit around the Sun? 365 days, or 1 year. During Earth's orbit around the Sun, it follows a nearly circular path, but with a small elliptical eccentricity. The Sun is not in the center of the ellipse, but one of the focal points. Bottom line, the Earth is a little closer to the Sun every January and a little further away every July. Does that cause us to have seasons? Let's think about it. We'd expect the planet to be a bit warmer overall when we're closer to the Sun. When does that happen? January. Is that our warmest season in the Northern Hemisphere? No. So the seasons must result from something entirely different. Let's return to the tilted axis of the Earth. As the Earth orbits the Sun, it goes through 365 daily rotations, while the axis maintains its tilt. On the June 22nd solstice, the tilt causes the North Pole to face towards the Sun, while the South Pole faces away. When the Earth's orbit takes it all the way around to the December 22nd solstice, the North Pole is now tilted away from the Sun and the South Pole towards. This tilt explains why the North Pole experiences winter in January, while the South Pole is experiencing the opposite season, summer. The North Pole is facing away from the Sun and gets less overall sunlight. The South Pole is facing towards the Sun and gets more. To understand this more fully, let's look more closely at how the Sun's rays hit the Earth. First, notice that halfway in between July and January, during the September 23rd equinox, the tilt causes neither pole to face away or towards the Sun. As the Earth rotates every 24 hours, each area of Earth's surface will receive 12 hours in view of the Sun and 12 hours out of sight of the Sun. 12 hours of day, 12 hours of night. Equal lengths of day and night is why this time is called an equinox. As the Sun's rays hit the surface, they are strongest at the equator, directly in the middle, where they hit at a 90-degree angle. As Earth moves towards the December 22nd solstice, the North Pole tilts further and further away from the Sun. At its maximum tilt on solstice day, the Sun's rays are now hitting directly at 23.5 degrees south latitude, or the Tropic of Capricorn. Notice that every location within the Antarctic Circle at the South Pole is getting 24 hours of sunlight. As the Earth rotates, none of these locations is ever lacking in sunlight. This creates the summer season for the Southern Hemisphere. In the Northern Hemisphere, inside the Arctic Circle, the reverse happens. 24 hours of darkness, winter season for the North. As we watch the Earth continue its orbit, the Earth's tilt again moves towards the Sun, such that when we reach the March 22nd equinox, we once again have all parts of the planet receiving equal amounts of sunlight and darkness. The equator once again receives the direct sunlight. At high noon, the Sun would be directly overhead here. Returning back to the June 22nd solstice, we see the tilt move the North Pole towards the Sun, so that the North Pole receives more and more hours of sunlight each day. At the solstice, the Northern Hemisphere experiences summer. All points within the Arctic Circle experience 24 hours of sunlight, and the Sun is directly overhead, providing its most intense heating at the Tropic of Cancer, at a location 23.5 degrees north of the equator. As we continue to watch this process, we can see that the Southern Hemisphere moves through this 1-year orbit from its winter through its spring, summer, fall, and back to winter, while the Northern Hemisphere experiences the opposite season. Note that each solstice and equinox represents opposite seasons in opposite hemispheres. The winter solstice in the Northern Hemisphere is the summer solstice in the Southern. That means that sun lovers can plan trips to maximize their sun exposure, traveling to the Southern Hemisphere in December, January, and February, and the Northern Hemisphere during June, July, and August. And if you're looking for the most intense sun on the planet, be sure to travel to the equator at the equinoxes, 23.5 degrees north in June, and 23.5 degrees south in December. Pause now.
Okay, so the lady, in fact, explained us to in a very short, say, whatever we have been speaking for the last half an hour. And I believe that both of this, my explanation and the lady's presentation together, may have put through what I was referring to. Uh, Let me also clarify one more thing here is that she was speaking about 66 and a half degrees and beyond all the points, either having 24 hours of day during summer or 24 hours of night during winter. Let me tell you that the threshold between 24 hours of day and 24 hours of night, okay, is basically 66 and a half, and that's why that's important say to understand what is the importance of 66 and a half degrees. Say that's the last point. That's the last point I would say that the duration of the day, I would say, could be measured in hours. That's one day, 24 hours. Because after that, the duration of the day, if it is moving into summer, and the duration of the night, if it is moving into winter, will rapidly change. From 24 hours, it will start moving into 2 days, 3 days, 4 days, weeks, and months, to the time it gets to 6 months, day and night, as far as the poles are concerned. However, I did refer to the fact that we keep speaking about yes, कौन? हाँ बोला की हाँ कुठे आले होते तुम्ही आकुर्डी रेल्वे स्टेशनला या तिथून पुढे मी सांगतो माझी एक मीटिंग चालू हं? बरं ठीक आहे करतो थोड्या वेळात sorry people about that, but that's a very important thing to note, that we are going to have the threshold, as I said, is 66 and a half degrees. It's still that point that you measure your daytime and nighttime in hours. The maximum that it comes to is 24 hours. It's 66 and a half degrees north and 66 and a half degrees south. So that's another interesting thing to note. Now we will be all putting all of this together to understand how climatic regions or climatic conditions in different parts of the globe are different. But before that, another important and interesting thing that we need to understand is to understand what exactly air is made up of, air particles, etc., how they behave, and so on and so forth. So I had another a short clip, and let me share it with you.
You may not realize it, but from the moment you got out of bed today, to the point where you sat down to watch this video, you've essentially been swimming. Why? Because air is a fluid just like water. It has waves and eddies, it flows, and when you push air out of the way, it rushes around you into a wake. So why don't we notice it most of the time? We commonly think of air as empty space. But while 1 cubic centimeter of interstellar space, the volume in the tip of your pinky finger, contains roughly 1 atom, the same volume of air has about 10 quintillion molecules. If that sounds hard to wrap your head around, it happens to be about the same as the number of insects alive on the planet, all crawling, climbing, and flying over each other in an enormous, tightly packed swarm. When this swarm of molecules runs into things, it exerts a force, pressing against the boundaries of the fluid like water pressing against the glass of a bottle. This is known as air pressure. And while air is lighter than water, all those molecules still get pretty heavy, with the total air filling a typical school gym weighing about as much as an adult elephant. So when you walk into a gym, how come you're not immediately crushed by the elephant of air in the room? Well, first of all, because most of it is pressing on the floor and the walls. And the part that is pressing on you is pushed back by the pressure inside you. You see, the air, as well as the water and everything else that fills our bodies, exerts an amount of pressure equal to that of the air outside. Of course, this is no accident. It's precisely what allows us to survive in the normal atmosphere, and what makes it more difficult at high altitudes or deep water. And we normally don't feel the air pressing on us because it's generally uniform. So even though different amounts of air molecules are hitting you at different times, the swarm is so thick that all those little differences average out. What happens when air pressure isn't uniform? This means that the molecules are pushing harder in one region of air than another, driving the airflow from the higher pressure region to the lower. We feel this flow directly as wind, and the pressure systems that meteorologists are always going on about are responsible for other weather changes, from the mundane to the catastrophic. But differences in air pressure do more than just let us complain about the weather. They're the very reason we're alive. We breathe by lowering the pressure in our lungs, allowing air to rush in. So the next time you take a deep breath, think of the unfathomable number of air molecules you're commanding to move. We look up at the night sky to ponder the infinity of space. But unless you're watching this video from that deep space, there are more air molecules in and around your body than there are grains of sand in all the world's beaches and deserts, stars in the visible universe, or both of those numbers combined. The vastness of the universe is right in front of you and inside you.
That was a bit more interesting as well. And just give me some more time. I will come back to you in just a moment's time. Okay, so with these two clips, we go back to the window that we were supposed to be sharing. We've understood a lot of things that we should have been as far as understanding climatology is concerned. Basically, remember, climatology is all to do with the energy that comes from the sun through the atmosphere on the surface, and how differentially it is received on the surface. Okay, what are the various reasons? Now, this is just one reason of differentiation. We are going to see different things. Now, when we were speaking about this variation, okay, okay, you'll see that these sun rays which are coming parallel to each other. So we'll see that at different locations on the surface of the Earth, as per the summer or the winter of that particular hemisphere, we'll see that the amount of units of energy that reaches the surface is different. Say, for example, a place where we are going to have places where yeah. Okay, so you see that the sun's angle, as it changes, the amount of units of energy that reach in a particular span of location, it's very interesting to note that, and that is what makes the difference of what we call as heat, and eventually we measure it in the form of temperature. So I say any place near the equator where the sun's rays normally tend to be around 90 degrees, you'll see that they are coming down, okay, the same 1 unit of energy. This 1 unit of energy gets displaced on an equal amount of surface. But the moment it starts tilting, say it's around 30 degrees latitude as such, or you see that the angle from 90 degrees, it falls to 45 degrees. Now this 45 degrees makes this 1 unit of energy spread beyond 1 unit. In fact, it goes to a distance of 1.4 units. 1.4 units of energy. The same amount of energy, let me tell you, the same amount of energy gets spread into 1.4. And the fun does not stop here. In fact, you move to a higher latitude. What you see is somewhere near, let us say, beyond 66.5 degrees, where the angle of the sun's rays is 30 degrees only. The angle of the sun's rays comes down to 30. Here, the same unit, the same 1 unit of energy that is brought by two perpendicular rays, parallel rays, gets spread into 2 units. Gets spread into 2 units as such. So obviously, where the insolation is going to be more, the energy of the sun is going to be more, and as a consequence. Now, understanding this very basic thing, how does this reflect on the surface? We do some part of this diagram today, and we'll leave it for the next part. Particularly this thing we'll do next time. But let me tell you that as far as okay, now what is going to happen? We have seen this, and we have we have been seeing this, that the equator is going to have significantly perpendicular rays of the sun. So this gets heated, and it's from here that it starts sending it towards the poles. Okay, latent heat and sensible heat moves from regions of regions of deficit, regions of deficit carried by ocean currents and atmospheric circulation, because both of these are major mediums of transport of energy. That's liquids and gases as such. The ocean currents are because of this. Atmospheric circulation is because of this. And what does this result into, or why does this result? Okay, you see that where the net radiation is positive, the incoming solar radiation exceeds the outgoing long wave radiations, and there is an energy surplus. Where is the energy surplus? Say from around 35 degrees south to around 40 degrees. Now again, you'll see interestingly, okay, it extends to higher latitudes in the northern hemisphere. It extends to lower latitudes in the southern hemisphere. I would ask you all to just try and look into why is it that it's not absolutely geometric, and in fact the energy surplus goes way into 40 degrees of latitude in the northern hemisphere, while the energy surplus is restricted to around 35 degrees latitude south only. Beyond which, of course, there is an energy deficit. Where the radiation is negative, there is an energy deficit. It starts getting cooler. Eventually, it starts precipitating in the form of snow. Where you have energy surplus, you'll see that here, particularly at sea level, you're going to have precipitation in the form of rainfall. I'm saying this particularly basically because within this you have the Himalayas, within this you have the Kilimanjaro, but both of them are more than 3,000 meters, and that's why you'll see that above that the precipitation obviously is going to be in the form of snow. Okay, so there are exceptions to all of this, but then that's how things are. And all that we have learned together today, okay, we will have to put it and understand on this particular thing. Okay, what is this? Okay, what they have done is they have taken temperature on one axis and they have taken months on the other axis. They've taken various cities in different parts of, I believe this is North America. So this is Point Barrow in Alaska, and then you have Winnipeg in Manitoba. Then you have, beyond US also, you have Cape Town in South Africa. And then you have Iquitos in Peru and St. Louis. And what they have done is they have plotted the temperature conditions of these places, these various places. As such, 1, 2, 3, 4, and 5. And it helps to understand why different places have different curves. Well, we put all of this together, and then we plot it on this, our information. Okay, and that helps us to understand what is why different countries have different types of climates. That, of course, is going to be for some other time. We're going to stop here, and I'll come back to our meeting schedule. And yeah, so that's all from my side
for the day as such. Just in case you have any questions and queries regarding whatever we have done, you could unmute yourself and you could ask me your questions if you have a question for the day. We have around 10 minutes. You could use a couple of minutes for having some questions exchanged, question and answers exchanged on either side as such. If you don't have your queries, I would stop